create some nice looking knitted fabric in Houdini. We'll explore some concepts like how to use uvsample to transfer a flat knitting pattern over to any UV object, and finally how to apply some fuzzy hairs on top for extra realism. So let's take a look. Alright, Houdini 19 here, empty geometry. Let's go quick because I have a lot to cover. I'll start by looking at this pattern and let's do some draw over. So we have a shape like this, and it repeats overall, and we also have 4 control points that we can create on the curve like so, right? So of course we are going to create just half of it and then mirror to the side, so we have everything procedural. So let's do that in Houdini. So I'll start with a line. 4 points are enough. Let's look at this line from the z-axis so it's frontal, and let me select a few points here. So point 0 and 2, let's move to the side, and also I want to make this point a little bit more close to the center one, and that's good. Now looking from the side view, I want to select both center points and push forward so we have this bulge, and that's good. We need to mirror the shape and finally resample that. So let's do, actually before resampling, let's do a poly path, just so that you have a single polyline instead of 2. So with that we can do a resample. So let's resample using subdivision curves, and let's keep to a very minimum segment count here, just because this thing is going to grow very large and very heavy. So now I want to go back to edit and just fine tune a few more points. So let's do something like this, and that looks good to me. Awesome. Now just copy and transform. So we're going to create a flattened like patch, knitted patch of fabric. So let's copy. I want 3 copies and translate to the side. Of course we want to go full procedural on this, so I'm going to use bbox here, so dx size. There we go. Now it doesn't matter the size of this thing, it's always going to connect. Now we're going to do the same for the y-axis. Now let's exchange that to the y, and here the only difference will be that instead of using the full size, I'm going to use half the size, so that the patches like they tie together nicely. Okay, so that's it. Now we can grow as much as we like with this thing. Just be aware to keep this into a square ratio, so it's always good to make it into a square thing. And also we want to stay into the 0 to 1 range. It's always better because we're going to use this thing to sample UVs, and UVs are most of the time always inside the 0 to 1 range. So let's do a match size, and instead of justifying to the center, I want to justify to minimum on all axes, and also scale to fit and uniform scale at the 1 unit, and that will give us this very nicely contained box. And that's it. Now we can just start moving on to applying or projecting that pattern into a geometry. So let's add a little bit more rows and columns here to make something more interesting. Maybe 20 by 9, something like that. So what we can do, let's create something simple as a start, a simple tube, and more height and more rows and columns. And now let's add also UV, so we can do UV project and set type to cylindrical, and there we go. We have some nice UVs. Let's just check it falls inside the 0 to 1 range, which is not the case here. So you see this thing, so let's make sure we have that all contained. So let's do an UV transform, and let's resize this and make that fit inside the quadrant here. There we go. And now we can also add some normals, so are important. I'm going to explain why in a minute. But yeah, now we want to transfer that over to this tube. How to do that? We're going to use an attribute wrangle and use the uvsample function. So let's do that, attribute wrangle. I'm going to call that project knitting pattern. So we can plug both here, and what we're going to do first is store the z depth, like this distance here from 0 to like this small distance, like the thickness. So let's store that in a float variable, so z offset, and that's going to be at p.x or .z, sorry. And now what we're going to do is to actually project the geometry. So to do that, also let's set p directly. So p will be uvsample. So uvsample of the geometry input number 1, which is the second input. What we want to query as an attribute. So just to give you an idea, this is going to query an attribute at an arbitrary geometry based on some uv value, right? So this is going to query, in our case, the point position attribute, so the p attribute, using the uv attribute as a reference, and the actual uv values will be the point position of this squared like this squared pattern. So we can use at p directly, right? That's it. So you can see right away, we can see it's projected to the tube, but it's also flat in the top view. And the reason why is because you need to reapply the z offset. That's why we have stored that in a variable. So what we can do is just sample the normal, the same we did here. Or actually, let's store that into a variable as well. So let's do vector projected position and vector projected normal. And that's going to be the same thing, but we are going to exchange p for n. There we go. Now at p will be the projected normal, the projected position, and we are going to add to that our normal. So let's displace. So we do p plus equals, so we are displacing. Let's add to the projected normal, but we are going to multiply that by the z offset, and also I want to have some manual control over how much I want to push outside of the geometry. And let's add a new channel of type float to that. So let's call that z multiplier, and that should give us a control where we can just push geometry outside and make that have the nice z shape as well. And there you go. Let's visualize that using a sweep node. So sweep, let's set round tube with grid and caps and small radius, and there we go. Now we have something like that, which is fine already. It's nice. Probably it's a good idea for us to have smaller shapes, like smaller elements, more resolution. So let's add some more rows in here, rows and columns, and yeah, that looks good. Let's add more rows so it closes, and that's nice. So we need to change the radius again, and that's really good. Okay, so you can see how easy it is. It's not difficult, right? So yeah, that works for this simple grid with a single UV island. I'm going to show you how to do that on more complex objects, but for now, let's work with that. So let's say I want to deform that, and before proceeding, I want to just drop a normal node to make it look better. So you can see if I increase the cusp angle, it's going to look better, right? More soft overall. So increase the cusp angle. I also can see we have like this horizontal line is taking too much space. So I guess we can go all the way back to the edit node here, and maybe let's see, we can maybe push that to the side here. Let's check the result. That looks better. It's tighter, you see, like that's better. Yeah, cool. And also now that it's tighter, we also need more columns to fill this whole tube. So let's go to this one here and add a few more columns. That's good. And yeah, so let's say you want to deform that to some geometry, and it's already working. Like if I add a bend in here, so let's add a bend node. So bend, let's add some bend. Capture region origin will be geometry d y min. Yeah, that's the syntax. I'm sorry. Direction will be 1 in the y-axis and length will be the y size. So let's do y size. There we go. Now we can bend, and if we hit enter, like you see, it matches perfectly the size of the tube. So let's do some bending, and like you can see, like it bends very nicely, like it works. So yeah, how can we simulate that and transfer over to some volume simulation or something? So what we can do is, let's simulate. So let's do a let's just not use the bend. What we can do is do a volume configure cloth and a volume solver. And let's add some ground plane. I'm going to push that downwards a little bit. This is good. And also I want to change a little bit the cloth settings here. So let's make the mass smaller. Let's check the thickness. Let's add more thickness to it. And also I want to make it more stiff overall and add more damp. Basically that's it. And if we press play now, we have a super rigid geometry. Let's go back a little bit more. So let's do more bendy like that. So even less, I should say, and higher damping ratio. Like so, something like that. So what we can do is now, let me check just real quick. Yeah, let's use that. So what you can do now is to instead of projecting, like instead of recreating that at every frame, because that works, but it's kind of weird, like it's not good and also very heavy. Instead, we can do a point deform. So we create that on the static geometry. So, and let's do a point deform. So point deform. So we are deforming these using a time shift, or we don't need that, just using the static geometry as a reference, and also this one as the deformation. And this is actually looking bad, and the reason why is because we need to change some of the settings here. So let's maybe up the capture radius a little bit more, like so. And also I want to use a delta mush soft because that's going to give us a little bit better results. So let's use delta mush, and we use this and this one. This is the reference geometry, not the simulated, but the like the threads itself. Yeah, so delta mush, let's see, gives a little bit more yeah, a little bit more smoothness to that. And finally I want to add normals again, so it's very nice. And there you go. Now you can see some really nice deformations here, and it's also not too slow, like it's actually very fast. It actually plays almost real time, not fully real time, but almost. Yeah, so that's how you can deform the objects. Now let's see how we can do some more complex objects, because this is a very simple tube with a very simple UV, like just a single UV island, and that's all good and works great. But as soon as we let's try, for example, creating the same on a pig head. So I'm going to throw away that simulation for a moment. Like, we don't need that anymore. It was just to show you how to create that. Now let's say we want to use a big head instead. So big head. If we plug that big head, and like the UVs for that, they are more complicated. If you plug that in there, like here, this is what you get. So very bad geometry, a lot of these spikes. So this is bad geometry. So how can we fix that? So the reason why we're getting these spikes are because we have a flattened pattern, and we have these UV. Let's visualize that. So UV visualize can allow you to view in word space. So yeah, that's what you have. And this visualizing to the centered word origin, but instead I want to view at the 0 to 1 range. So I'm going to transform 0.5 units in both x and y axis. Now we can see both overlaid. So yeah, what is happening here? Every time one of those patterns are outside of the UV shells, they are not finding the proper position where to sample from, and you are having spikes because the geometry is stretching. So what we want to do actually is to array all these patterns over the UV islands, and then blast everything that's outside of the shape, like of the UV shape. So that's what we're going to do. The other thing that we want to do is to break that pattern projection into many, like into one time per UV island. So we're going to do that with a for each loop. So let's do that. First thing is to let's subdivide this a little bit just so we have more geometry. And now what we want to do is to do a UV vertex split. All right, vertex split can break your geometry by some attributes. In this case will be UV, so it will break at each UV seam. So you can see right now we can select parts according to the UV islands. So that's one thing. Now we are going to also promote to point attribute because you want to flatten that into this 0 to 1 UV space as well, and promoting to points will make our lives much easier. So now we can do a for each connected piece. So for each one of those pieces, let's do single pass for debugging purposes. So for each one of those, I'm going to do an attribute Rango, and we are going to go to UV space, and it's as easy as doing at p equals at UV. That's going to transform the geometry into the UV space, so it's flattened here, like you can see here. And the other thing I want to do is to let's ray our knitting pattern on this geometry, right? So we're going to ray, but not transform the points. Let's uncheck that. And also let's change direction to vector, and let's do -1 in the z-axis. So we are shooting rays from this blue geometry here backwards. And one thing we need to do real quick is to set the point z value to 0, right? That's it. Good. All right. So yeah, 0, and then we should raise, and we should raise using the -z-axis, and we are not transforming points, but instead we need to create a point group for the ones that are hitting the geometry. And we can blast the points that are not hitting the geometry. So we can blast hey read group and delete non-selected, right? So that's what we need to do. We need to do that actually before projecting, so it's here. That's better. So that's what's happening. So we went from this thing where you have everything, like all the square, down to this thing. So we're just working one piece at a time, right? So this is leaving some disconnected points. Don't know if you can see that, some gray dots here. So just for good measure, I'm going to use a clean swap to remove unused points. That's it. Cool. So with that set, we can now reuse our project knitting pattern node here. So let's move the sweep down there, and let's reconnect so we can use this one here. Is that correct? No, it's not. This one here, and the second input is the geometry before the UV space. That's it. Yeah, okay. So now we have the ear, and let's uncheck single pass and see the whole thing working together. So sweep node, there we go. Still not looking too good. A few reasons. First, because our resolution is too low. We need more shapes. Second thing is you can see here we have lots of big shapes, and the reason for that is because our UV islands are not proportional to the 3D surface area. So we can always fix that by using a UV layout node. So let's do here. So UV layout node, and we want to check scale islands to match their surface areas. There we go. Now it's fixed. And also let's try and make more. Sorry, I'm saving that because I don't want to lose. So let's make more shapes. Let's add a few more rows and columns. Let's make that look better. We need to increase that one accordingly, otherwise we're going to have gaps in our geometry. And finally, what we need to do is to reduce the radius on the sweep node. Just something like that. Right, so now you can see it works for more complex objects. Maybe want to go even more resolution, and you go with maybe, I don't know, 150. Too much, maybe 100 by 100, or maybe more. Needs to form a square aspect, so something like that. Let's see what that will give us. And of course reduce the sweep radius. Let's do 0.07. That is better, and there we go. Very nice and clean, and interesting geometry for knitting. And now, for example, like the UV shells, like the rotation, they play a big role in defining the pattern direction. For example, if you want this area on the head to run like downwards here, you can always go back and rotate the UV island on that piece, and that's going to face like make the threads run downwards. So let's do that real quick. So if you go to your original geometry, and or after the UV layout better here, so if you just rotate that down a bit, and let's make that smaller so it doesn't overlap, so that will make your threads run downwards. This knot, there you go. So yeah, that's how you can control the pattern direction, and as you can imagine, you can go crazy with that. So yeah, that's really neat. So now, as the last step, I want to show you how to create some fuzzy hairs on top of everything, just to make the thing more realistic. So let's take a look. So I want to grab a hair generate node. So yeah, let's make the hairs a little bit more fuzzy overall and more curly. So what I want to do is probably add a guide process. So guide process makes it everything procedural. So what we want to do is to let's do a bend before everything. So let's bend, and let's bend let's see, 120 degrees, and on top of that we're going to add some freeze. So let's add freeze. That looks good, I guess. Final step would be to add some random lengths. So we can do multiply, and then method would be cut or extend and randomize. So that goes from minus or 4.3 or 0.2 to 1. That's better. And the one thing I also like to do is add another guide process. So guide process, and I want to create a 5% of hairs that are like really stray hairs, like larger, that really pop out from the silhouette. That makes it very nice. So let's go with a mask before everything. So let's use a noise mask, and frequency needs to be very high. Let's go for 1000. Gain is also high, bias is low. So just selecting a few of these red guides here, and with that set, we can unvisualize the mask, otherwise it's going to propagate downwards the tree. So now on operations, you can do set length, and modes is multiply, and instead of cut, you set scale. So we're growing the entire like the strand as a whole. So let's do randomize, and it's maybe 1.3 to or 1.6 to 3, something along those lines, just to create some stuff that pops out of the average. And that's it. Now let's deform the hairs with the geometry. So to deform, like in case you want to simulate that, the easiest way is to use a guide deform node. So we are deforming this geometry using the rest pose, which is this one. So the rest pose is the meter itself, and well, we don't have any simulation right now, but we can do one. Let's do one real quick. So let's do actually you need to do the point deform before everything. So let's do big head. It goes here. So let's create, or let's simulate on the low poly one. Do we have enough resolution? We do, yeah. So let's do a vellum configure cloth, and this is again lower density. It's more thickness. Bend and damp ratio. Let's do a vellum solver. I'm on 74 already, so let's go back to frame 1. Now here we add a ground, and let's push the ground down a little bit. Still trying to compute 74 for some reason. Let's do reset sim and push the ground down and let it simulate. Let's see what we get. Let's do this thing. Looks very cool. So yeah, we want to deform using that before creating the hairs. So again, it's trying to simulate all the way for some reason. There we go. So let me show display operator. So let's first deform this geometry, or actually the sweep, like this geometry. Let's deform this one to the vellum sim. Again, to do that same thing, let's time shift to frame 1, like the rest pose, or we could even like add a rest position here, but that's good. So we time shift to frame 1, and now we do point deform. So we deform these using these reference pose and these deformed pose. Let's up the radius a little bit. or maybe not much. That's better. And let's go with that. I'm not those, or yeah, let's use the delta mush. Maybe less points could be make this thing much faster. That's good. Let's use the delta mush. So this geometry with this reference frame and or reference geometry, and doesn't change much, I guess. A little bit better. Let's go with that. So yeah, we have, this is starting to become a bit heavy, but still like kind of manageable. Still can look at that, very nice and easy. So yeah, let's now deform the hair to follow this simulation. So the way we do that is again using this guide deform node. So let's push that to the side. So we have the groom, we are using the rest skin, and the animated skin is this one. Or better yet, what I always like to do is to time shift instead, just in case we have something changing point counts or whatever. I just like to go this way, it's safer, so nothing is changing point indices or stuff like that. There you go. Now it's deforming your guide hairs, and finally we can merge both. So we can merge the hairs to the deformed geometry. So shift click on the inputs and alt click to add the merge node. There we go. Now it's nice. It's deforming to the underlying geometry, so you can see the hairs are not doing any crazy stuff like flipping or nothing like that. It's just nicely following the underlying cloth movement. So there we go. That's how we can create this sort of nice looking knitted cloth. And just because it's Christmas time, why not a good sweater like this? So yeah, that's it from me, guys. Hopefully you enjoyed this one. If you have any questions, leave in the comments. I will take a look. And until the next year, take care and goodbye.